Community meeting. Today is Tuesday, October 4th already, 2022, and I will try sharing my screen here. We are have this meeting every other month on the first, oh, actually that got changed. It is the first Tuesday of every other month, and we have, if you have any prior meeting requests, send them to me for any kind of topics or anything or any ideas, even if you don't want to present, but you'd like to see something, I'd like to hear about those as well. We take any kind of discussions for Builder, Podman, Scopio, any container images, and as you'll see today, even especially so, tools and other projects that use Podman, and we'd like to hear about that as well. We have our meeting notes in the HackMD. I'll put those in the chat as well. If you have not yet, please go ahead and sign in through HackMD. So for today, we have a couple of great topics I'm looking forward to very much so. One is about a Distrobox demo from Luca Di Maio, and then Alex will be talking about the Vault test suite after that. And then we do have a little talk we had put aside about the Podman on Mac installer update. I'm not sure we have a whole lot to say about that, but I'll put Brett on the spot and we'll chat that through. And then after that is all done, we'll have some time for any open forum questions or comments or questions or any other thoughts that you might have about Podman. So given all that, I'm going to stop sharing and I will hand it over to Luca.
Thank you, Tom.
Sorry, my machine is being slow at the moment. My Blue Jean screen is not coming up. Repeat. Right that way.
Okay.
Okay, there you go. Sorry about that.
No problem. Cool. So, hi all, I'm Luca. I'm a DevOps engineer, and today I will show you Distrobox. What is Distrobox? So, Distrobox is a POSIX shell wrapper around Podman. It's thought to be simple to use, and it wants to abstract most of the complexities in order to ease the use for users that are not very familiar with containers, right? So what it does is creating containers to be thought as pet containers more than, cattle containers. What you do is create an entire user space, which is separated from the base operating system, instead of just an app like a Flatpak or a service like you can do with a regular container. And to do that, why not CH roots, but using Podman? Well, Podman because it's battle tested and it's simpler to use than CH roots, and it gives us access to a wide variety of images and gives us also an interface for image management. And simply, it's very, very, very solid for rootless use, which is very important for this use case. Contrary to a normal container, this has a deep integration with the host. So the container is able to launch Wayland and X programs, use Pipewire audio. It shares the agents for SSH, GPG. It automatically generates the desktop entries for new created containers, as I will show you later. And it blurs the line between what's on the host and the container, because it integrates them in a way that you can launch host commands from inside the container and vice versa. It supports user systemd, user dbus, and optionally can use the Podman ability to integrate with systemd to launch a separated systemd instance inside the container, as we will show in a bit. Being the simplicity of use is the main goal, so it's not a lot of commands. just have create, enter, list, remove, and stop. Some utilities like upgrade, which will just cycle through all the containers and upgrade them using their package manager. It's different from the auto update that Podman uses because we cannot just delete the container because these are pet containers. It's something that you care about. It's not something that you just throw away and create new one with the new image. So it has to be done using the package managers. There is an ephemeral command which mainly is very similar to the run --rm of Podman. And then there is the generate entry utility, which creates desktop icons to launch the containers easier. So the use cases is thought of is obviously for immutable desktop, Endless OS, Fedora, Silverblue, Kinoite, hopefully Kinoite, OpenSUSE and MicroOS, or lately it's gaining traction even on SteamOS, on the Steam Deck, thanks to the work of the Podman statically compiled builds. And I just written a simple script to install Podman in a rootless manner in the home of the user, so they can use it without having problems with immutability and read-only operating systems. And the main target in this case is to minimize the base operating system bloat. So you have less moving parts that can break. Userland can be easily replaced because it's still a container, and it's easier to make a complete system reproducible. And one of the use cases that really started why I started the project was a completely sudo-less setups, like in an enterprise environment where you are given your work laptop where you cannot do sudo, but you need to do your job, so you need to use a package manager. And it was simply easier to just use containers at that point, and with Podman rootless containers. And you start with creating a simple script that launch Podman with a bunch of flags, then that flags grew, and you start putting some logic, and then you have a project. And so also it's very, very, very handy for software compatibility, because sadly not everything is a Flatpak yet, or can be a Flatpak yet, and maybe you need compatibility with newer software if you are on a LTS stable release, like on CentOS or Red Hat, or you want access to older software. And Distrobox can ensure compatibility almost 10 years back in time, because it goes all the way back to CentOS 7 and Debian 7, and with a couple of tweaks, even CentOS 6. So it's quite old. And and it's compatible with all major distribution that supports Podman, really. And we can go ahead and show something. So let's start with, Distrobox has a series of commands. You can list which Distrobox you have. The output is very familiar. It's very similar to the Podman one because it is. And it's just added some colors to make for the user more obvious which container is running and which container is not running. You just enter. Sorry?
Can you make the text just a tad bit bigger? Perfect.
Better now? Yeah,
yes,
sorry.
Much.
And so to enter, you just enter and you can choose your container. Differently from a normal container that you launch with Podman, you see there is some sort of progress bar, because there is a lot of stuff that is done during the initialization of the container, which is aimed to integrate it with the host. So for example, now that I'm inside the container, this one can see all the host processes. So it's using host namespace for everything. And one of the example is having access to the local user session of systemctl. It's very handy, and yeah, mainly you can use it as your normal environment. You can install, for example, let's install AbiWord, for example. Yeah. Okay. So if you launch it, it works, and it even integrates with the theme. It's launched transparently, as a normal application. And this integration goes even deeper than that, because you can, for example, export this application. So right now, if I open a new tab and want AbiWord, obviously on my host is not found, I can just Distrobox export it. I don't know which. So I've exported AbiWord on the host. So now I can just use it transparently from the host. The container has full access to the home directory of the host. So you can just use it to open files, like it was a regular application. But even better, you can just export the application itself. And it just shows up in a second here in the application list, and you launch it normally. So it can be used as a compatibility layer of some sort for whatever software you need, like, for example, having access to PPAs or AUR on or Red Hat or CentOS on Fedora or whatever. This works also for, as I showed, for binaries, for graphical application, but also for systemd services. So, for example, here I have a simple daemon inside the container. This is not an init full container. This is not running a separate systemd instance inside the container, right? So if I want this service to run, I can export it. This is called daemon.service. So as you can see here, it creates on the host user session the daemon, and if we cut it, you can see it just wraps it around the Distrobox command. So you can just start it, and it works. Personally, for example, I use this for some software that needs to be a daemon, and being on an immutable system, it's a bit of a problem to just layer it. So I just, for example, use syncthing in this way. And Distrobox supports also using root full containers, not only rootless containers, but just specify it. You can see obviously the list is different because it's querying another set of containers, and I can, for example, show you. This one is an init full container. So this one has separate systemd inside, because inside here I installed actually KVM libvirt. So here it's libvirt running inside this container, and here is virt manager, which is installed in another container. Actually, it's running on another Fedora container, and it's connected to this libvirt running inside this rootful container, and I can use virtual machines without having to layer anything on the host. I can simply scrap this container if something is not working, or I can backup it and I can, save it, restore it somewhere else using Podman save and Podman load utilities. And yeah, so the flexibility, it's obviously coming from the Podman side. What it does is simplify things for the for people that are not really into typing a lot of flags inside Podman command. And actually, you can extrapolate the Podman command simply using dry run. We'll pretty print it. So if you see, this is a pretty long Podman command, but it's just a common Podman command where the interesting bits are obviously using the username space keep ID. So your ID inside the container, this is the same as outside, so that you can have an integration of the files and permissions and so on. This is the enter command, which is just a Podman exec, where I just extrapolate whatever is the default shell set for the user inside the container. So you can also have different shell inside these pet containers. And yeah, so this is the create command. It's a lot smaller. What it does is simply, create it. It has some level of volume integration from the host. It mounts the complete host root inside run host. This is useful for some a series of reasons, like keeping in sync for DNSs, host names, and so on. And then the rest of the integration is done in the entry point, which is a separate piece of Distrobox where all the package are handled, mounts, sockets, and all this stuff. And so mainly the target is simplify the use of Podman for this specific type of containers and use cases. It's heavily inspired from containers toolbox, actually, which I started using on Fedora Silverblue. It's just that I've found my necessities to be a little bit different, so I started another project, and then here we are. So yeah, this was Distrobox.
Really nice. Does anybody have any questions for Luca? See, this is a super cool comment from Mark.
Thank you.
Okay, last call for questions for Luca. I'm not hearing any. So, Luca, thank you very much.
I do have a question, Luca. Like,
sure.
I was wondering, like, how it is like different from Toolbox. Like, what are the things that you didn't like in Toolbox, and why did you create Distrobox?
Sure. So it's the core concept is it's the same, right? What's different is just in the implementation of, so Toolbox needs a dedicated image. Okay, you need like when you create a toolbox, you have like a Fedora Toolbox image or a RHEL 8 image and so on, which have to contain a set series of packages. And I just believe that you can do that in the entry points, and that's what I do. And then it started implementing different things, like the possibility of having a custom home folder for the containers, having custom shells for the containers. So it started diverging a lot. So what I would say the major difference is that Fedora Toolbox or Containers Toolbox is very much Fedora oriented, and you need to have a dedicated image for it to work. With Distrobox, you just can throw a normal cloud image to it, and if it's inside the container manager compatibility, it will take care of everything for you. So actually, we are waiving about 65 permutations of operating system and versions as a compatibility. So it ranges from Debian 7 to Arch Linux to, I don't know, Gen 2, if you are into that, in Slackware. So Clear Linux also. An interesting point was actually I did some research with Michael Larabel from Phoronix, and we did a series of benchmark, and actually we benchmarked the overhead of Podman itself, which was lower than 1%, and Clear Linux container was faster than the host itself because of the Clear Linux optimizations, Intel compilers and stuff. And so, yeah, I think the strong point is the wide range of compatibility.
Thank you, Luca.
Thank you.
Anybody else? Okay, then given that, I think we'll move on to Alex, and he's going to be talking about the Vault Test Suite. Alex, it's all yours.
Thank you, and thank you, Luca. I definitely don't think my talk's quite as interesting as that one, but I shall try. So, let me just click. Yeah, so for people who don't know me in particular, I was an intern at Red Hat back in 2017 and 2018. I actually sat just down from Tom in Westford office at the time in the 2017 internship. So that was a lot of fun. I wasn't actually working on Podman, but I definitely learned a lot about it. So I currently work at HashiCorp on our Vault product, and you can say a lot of things about Vault besides that it's open source and it's a security manager. But I think the interesting thing that I want to point out is that we also kind of believe in an open ecosystem as well, if I were to phrase it that way. And HashiCorp in particular plays an interesting role in that we try and integrate with just about everyone. We try and partner with just about everyone. And we try to be more of a base layer. And one of the interesting things about that is it means you got to test a lot of different things. And Vault, being more of a security tool, does things like dynamic secrets. So you have to spin up, a MySQL database and test whether or not you can provision credentials into MySQL database, but also MSQL and, test authentication with Radius and all of these different types of things. And using containers is something that's been done well before my time here at HashiCorp. And I kind of wanted to walk through one of the problems I had running Podman on this test suite, and then how I ended up solving it and what I kind of think the direction for part of this test suite will be. So with that said, how I use Podman is actually rather interesting to start too. These are just kind of my notes over here. But I use Podman on Ubuntu currently. This is HashiCorp's preferred distro. But when I was running on Fedora earlier, I noticed that Vault's Go test suite will directly talk to a Docker daemon. And so I was using Docker for a period of time, but I asked a question on Pound Podman on IRC about, is there a way to replace this with Podman? And so now I have this little alias that I use Podman that enables the user mode socket and just exports it as an environment variable that our test suite will then pick up and use Podman rather than Docker. So if we were to, kind of go into Vault right now, and check out this commit that is an older commit. I can tell you right now, systemctl, docker d, status docker d, Docker isn't installed as a daemon on my system. Docker, the command line is, but if you were just to run it right now, this test would fail or pass, maybe, depending on if I've used Podman before. Docker host exists, so it was indeed provisioned. But if I go over here, Docker will fail to connect because it doesn't exist and it wants to talk to real Docker. So using Podman, I can then run this test suite now transparently to it with Podman, which I rather like. There's a whole business with some other containers that use a lot of memory on Docker, and I haven't figured out why. But running them on Podman just magically made them work, so I'll get there one of these days. But this particular test suite is interesting because what we do is we're trying to test our authentication with the backend Radius D server. And it will eventually time out in this particular step, with the context deadline exceeded error. And I wasn't quite sure why. And this only happens on Podman. And so I was kind of digging into this a little bit. And we have this whole infrastructure of, we call it a service. We spin up a container instance. We talk directly via the Docker API to these containers in Go. And, it roughly behaves as you'd expect. At least knowing less about the container ecosystem there. But what I noticed is if you add, some debug information in, Radius D has a debug command, and you can save this log output in our environment. And if we run this, what we see is that the reason why it fails is because this particular container is expecting a certain set of networks. And the reason why it's timing out is because the Radius daemon has a allow list of networks that it prefers to use and prefers to accept clients from, and we're contacting it from an unknown client, from an unknown IP range, and so it's simply just ignoring the auth request entirely. And this is a property of Radius. And so I had filed at the time a pull request against this particular dependency container we were using, saying, hey, is there any chance we could add in the default Podman range? It hasn't been accepted. But if you kind of click through, last commit was on 2020. The container itself is kind of old, and so it kind of got me started. How much flexibility do we actually have in this Docker API to do what we want? And of course, the answer is, well, you can do whatever you want. You have all the flexibility because you can translate your Podman CLI commands into these Go API calls and do whatever you want. So we check out this later commit. What I started doing was I was like, oh, let's start fixing this problem, in a better manner. It turns out that our CI was also now starting to spin up other Docker networks as well, and was also failing with the same bug. So I'm like, oh, I already solved this for Podman. I always found the root cause with Podman. So we ended up taking a hammer, and the hammer I happened to see at the time was, oh, let's just run commands. So I ended up doing a container exec create and calling two commands. First, we provision in our new config, and given that I had a hammer, Echo seemed like a good hammer, good tool to use, and then run the radius daemon itself manually because I didn't really know how to send a sig up or if it would respond well to the sig up. So I ended up changing the entry point to sleep and doing that. But again, this passes now. But it's not ideal because I think what you'd like to do is you'd like to perhaps do a container file and explicitly provision your allow list client broad open access file there, and then just spawn the container as you would normally. And of course this now passes. So I ended up finally getting around to doing this. And so what I ended up having to do was I was kind of asking on the Podman channel, hey, is there a more general way of translating Podman CLI commands into API calls? And I mentioned that I was interested in container file building in particular, and Nolan got back to me saying, hey, the secret is you need to build a tarball. And I was like, oh, this makes a lot more sense of how it ships off the context to the daemon. Is it powers the local directory that you're building from and pushes that tarball up. So with that little secret, I was finally able to understand the comments in the README. All I was working off of was these set of Go client docs for Docker, which are a little obtuse sometimes. But I saw image builder. I was like, oh, there's a context here. There's a builder context. An IO reader, or what really is what my question was, but it's a tarball. And so what I ended up building now is a way of creating your context from code, not necessarily reading off a file system, but just kind of creating it in the test case itself. We can go create a container file based upon this currently outdated image. We can just copy in that change we want to make. We can go build it, and if we go look at what this actually looks like on the back end, it roughly looks like what you'd expect. You add in your container file, because that's one of the tricks, is your container file actually exists in the tarball context as well. It's not just a string that you pass in. You build your tarball, you send it up, and you just do a regular image build, and that's all you really need to do from an API perspective to do the equivalent of build a bud. So that was rather cool. But now we pulled out that entire hack of using SH, using echo to go write files into this container and then starting it manually. It just, works as a regular port with the regular entry. So, and that, passes the test suite, of course, as well. But the last thing I've kind of started doing on top of this is now we can also think about copying files in and out of a running container. Not only do you have, exec capabilities, you can run commands, either in the foreground with the output or in the background. But what I've started doing is building a whole integration test. And Radius is an interesting problem set, but Vault also includes PKI, CA infrastructure as well. And that's primarily what I work on. And the issue with PKI in particular is it doesn't necessarily matter what you do. It matters how that behaves in the wider ecosystem of applications. Does it work with OpenSSL? Does it work with other things? And we can spin up a Vault test cluster, and we can create certificates. We can sign an entire chain now, and then we can drop this in an Nginx container. And this is just an arbitrary server container that I happen to like. I like Nginx for whatever reason. And we provision all these certificates in with a very minimal container file. We set up a bit of a listener, and I need some known good strings to test against, so I provision a fake website in. And this spawns a container with the particular test data that we have, and Nginx uses OpenSSL in particular. And so we start to get one piece of that picture. And the cool thing that I'm doing is this container obviously has a whole host, an alias port that allows the Go test to talk to the container. But it also exists on a Podman network off to the side. And you can provision other containers onto that same network. And so what I do is I also build, just from Ubuntu, since I happen to know curl and wget behave differently on Ubuntu. Curl is using GNU TLS and wget is using OpenSSL. So now we get another two pieces of an integration matrix. But we provision this other testing container onto the network that Nginx sits on, and we can talk over that network, container to container, and verify with a different set of commands that might natively exist on the system that these certificates are good, and that they work in an interoperable manner. But this base image, there's two different types of containers here. This Nginx container gets dynamically provisioned for every single set of test data that we have, test scenarios. We share a single base image that we build once for a wget container. And so this only gets built once, and then we copy into the running container via these copy to, copy from helpers down here. We can copy in the certificates that we actually want to test with in the wget in the curl instance, and not have to rebuild that entire image every time. And then we can just run the curl and wget commands in this sample container. And so if we were to run this, what this does is we share a little bit of overhead cost for each of these different scenarios. To build the wget one, we have a bunch of overhead. To build a different Nginx container for each of these, since there's a lot more work in building this Nginx container. in the certificate provisioning step than in the wget case. But you can see here that these particular certificates work well. They're able to use wget, they're able to use curl or whatever to connect to our container over the local host. We're also able to use Go within the test suite itself to connect via that expose port to the container and validate another scenario. And then all in all of these different scenarios, we had a bunch up here. Where are we here? All these different scenarios can now run in parallel. And so they don't take, relative to the rest of the test suite, they don't take that much time to execute on their own. So that's kind of what I've been doing. I think the next step is I'd like to be able to expose the Vault cluster itself that's running in our test step to these containers and kind of do the reverse direction. Currently, we have ways for the test to reach out to the containers and the containers to talk among themselves, but we don't yet have a way of the container talking to Vault, in this case, talking back to the test scenario. And we can spin up Vault test clusters with local listening ports. But they exist on the host's local host binding. And so I'm guessing what I'll have to do is I'll have to use another container and provision some of the artifacts we want to test with the OCSP response and the CRL into this third container and have the containers talk to that rather than talk directly to Vault running in the test case. But I'd be open to suggestions and thoughts from anyone. This last bit is still a little bit experimental, and I'm tweaking some things before I, merge it all in. But yeah, that's how I've been using Podman here at HashiCorp, and I'm happy to answer questions or anything.
Great, thank you, Alex. That's very interesting. Anybody have any questions for Alex? Comments, suggestions? Sounds like you covered it well, Alex.
Thank you. Yeah, it's been a learning experience with the old Docker API versus the Podman command. It's been fun.
Yeah, looks like you made good progress with it. So next up, we had kind of a soft talk about Podman on Mac installer update. Brent, do you know what that's all about, or do you have anything to bring up on that? And it looks like Brent ran away.
I guess.
Yeah, Ashley, go ahead.
I guess we have a package installer. I've been building signed ones and putting them onto the GitHub releases. And then also we build unsigned package installers in CI at the current moment. So if you're curious about, if you want Podman on a Mac and you want to do it via an installer instead of Homebrew, they do exist now.
Okay. Do we have any links or pointers that we could add to the chat so we can?
Sure. It's just on their GitHub releases. We're doing signed ones for all our releases and then unsigned ones for our.
And unsigned ones for what, Ashley?
Unsigned for RCs.
Unsigned for RCs.
So you can, there's a .pkg file.
I know some people don't really like to use Brew at all. I've heard that from a number of people. So it'd be nice to have that available for them.
Yep.
Right. Any questions about that for Ashley? Okay. Great. Given that, I'm going to go into our open forum questions. Are there any questions over any of the talks or any other questions unrelated to the talks that you'd like to discuss today? Very quiet group. Ready.
Can I ask a question regarding containerd, like running Podman on an EKS cluster? I know it's unrelated to the topics you guys been talking about. I can reserve for later, or can I ask that question here?
You can ask. No guarantees that we'll get you an answer that you want, but we'll go ahead and ask it.
Okay. So basically, what I'm trying to do is I'm in a DevOps team, and we run about 500, 600 Jenkins builds a day, and we use we basically spin up containers on an EKS cluster. The thing is, we are trying to move from Docker to Podman. That's how this thing started, because the Docker shim got deprecated. So currently the way we use is using the Docker socket, basically mounting the Docker socket from the Kubernetes node into the container, which is not very secure. So that's why I'm kind of like exploring kind of a Podman to move on to Podman. I got it working rootless mode, but the problem was, unfortunately, it was about the build were about 3 times slower compared to the Docker. So I asked this question on the Slack channel, and I think Matthew kind of explained why that might be, and he's right. So in rootless, apparently they have to do a lot of storage and network redirection. So the performance get degraded. So I started running in root as root, and it did make a lot of difference, like using kernel overlay as opposed to Fuse. The question I wanted to ask was, is there anything else I could do to speed up my builds using Podman?
Well, you could try just having a mount point. I had a similar problem with my tool, and if you have the build stuff or IO intensive stuff in a volume, which is like shared from the host or whatever, it doesn't go through the overlay. It just goes straight to the disk, so you shouldn't have a performance penalty. It may be a little bit harder, maybe because you have maybe a lot of concurrent builds, so you will have to organize that. But if you go with -- volume and just probably also an anonymous mount is okay. It doesn't go through the overlay FS. You shouldn't have any performance problem in that case.
Yeah, this is something similar, Luca, that I'm kind of experimenting now. It uses barlib containers. Podman uses barlib containers. So what I'm trying to explore currently is that if I do NFS mount, and then I mount basically barlib containers onto that NFS mount. So all the containers, all my Podman containers can share already downloaded image. So if that works, technically only the first time the image needs to be pulled down from the repo, and then the consecutive builds from can be used from the cache. But our platform team saying, I don't know much about the EKS and AWS side, and apparently they're using you're saying that for the NFS I have to use EFS. And apparently EFS is so bad, like in terms of like bandwidth, data transfer, and it's expensive too. But the thing is, we can justify the cost if he's going to save a lot of time. but apparently the performance is pretty bad. So this is what I'm kind of trying, but I am kind of running into an error which I'm kind of looking into. But would you say that's something kind of worth exploring from your experience?
For the NFS route?
Yeah, mounting valid containers onto an NFS.
Yeah, probably if it's much simpler, to have a price point, yeah, probably it will be a lot cheaper if you just create an internal NFS server inside your EKS cluster instead of relying on, the Amazon one.
Right.
Just because at that point, yeah, you can go a lot faster. I don't know. It depends obviously on the instance type that you use, for the EKS cluster, and if you have the network optimized ones, I don't remember that. No.
Oh, okay. Yeah.
The name you should have a 10 gigabit bandwidth, which is plenty, I think.
Right.
I don't know
we
even
used to see, we use C6. We use C6 for AMD and C7 for ARM. I need to check the bandwidth, the diops.
But yeah, I think that at one point NFS protocol itself will be a bottleneck. So probably you don't even need 10 gigabits.
Right. Currently, what I have set up though, what I've done is I created a directory on the Kubernetes node and then mounted that into the container. But the only thing is, only those containers running on that node can share the image. So it's not shared between the nodes, different nodes, because we have a cluster with say 20 worker nodes. So the caching is per node as opposed to per cluster. It's working great, but I was looking for some suggestion that
you could just use a persistent volume claim and then share that. Right. Probably you could have a network overlay, obviously, of performance, but
guys, I squashed the conversation, but we are running out of time.
Yeah, sorry.
Thank you.
Yes. Could I suggest, Puvi, that you bring this up either as a discussion within the GitHub for Podman?
Sure.
Do that there, or set to the Podman mailing list, whichever you prefer. Either one would work. Great there.
Okay, sure. Thank you so much.
Oh, no problem at all, and thanks for bringing it up. I hope we can get it all fixed for you. So just briefly at that, if you have any topics for the next meeting, which will be on Tuesday, December 6th, 2022 at 11 a.m., send them to me or add them to discussion topics that we have out on the Podman site on GitHub. And then also our next Cabal meeting, which is where these meetings here, we do demos and such as we've done today. The Cabal meetings, we spend more time for discussing things that we'd like to do in Podman in the future, a couple months out or a year out or what have you. So the next Cabal meeting will be on November 17th, also at 11 a.m., and that's on a Thursday. Those run every third Thursday, and these community meetings run every other Tuesday, the first Tuesday of the month. So with that, I'm going to stop the recording and thank especially Alex and Luca today and Ashley for hopping in and doing a great job on the presentations. So thank you all.